Hi, this is Dr. Don again, and we're back with Martha's data, and we're going to do some more analyses of the data, and really we're just going to play around to try to get a feel for what's going on with this data. And again, although I'm using this simulated data set I made for Martha, these same sorts of analyses you should consider, when you're looking at your individual data sets and looking at the relationship among the variables you have, the questions, and what the responses were. And so let's just look at those a little bit. I'm wondering, one of the key things that one might be interested in is this understanding training column there. Understanding what is the next training that I need to do. And I'm wondering if it matters whether or not it's a male answering these questions or a female answering these questions. And one way we can check that is to do a couple of tests. One test that I like to do is look at the pattern of answers, and we'll do that with going to Stat, Tables, Contingency Table with Data. And we bring up this dialog box for a contingency table. And really when we're doing a contingency table, this is a chi-square goodness of fit test. And I'm sorry, test for independence. I'll get it in a minute here in a second. And what we want to do is select our row variable. And the row variable, we want to use one of the demographic columns. And I'm interested in men and women. So I want it to sort that way. And then the column variable is the actual variable that I'm interested in, which would be the understanding training. And I'm not going to group it this time. You can, and I'll show you how to do that. I want the expected count so I can see what is expected if men and women are the same on this. And I want the chi-square test for independence. And I'm going to click compute. And so we get results here. And this tells us the row again. This is males, females. Males are 1, females 2. And then we've got the 6 bins that Martha set up in her data from lowest comfort with understanding what to do to most comfort understanding what to do. And we're trying to see if the pattern between males and females differs statistically significantly. And the test is telling us no. We've got a p-value of 0.4, which is much greater than 0.05. So there is no statistical difference between the patterns of men and women and how they answered that question. And the in parentheses is the expected count. If you remember all of the inferential tests, we have the observed minus the expected. We compare the observed versus the expected, and if that difference is more than a critical value, then the significance is significant. So this is a contingency table. Let's look at another way of looking at it. I'm going to close that, and I'm going to go back to Stat. This time I'm going to do Z-stats to sample with data, and I'm going to select again understand training, and I'm going to select skills currently, and we're going to test a hypothesis there. Is there a difference in the mean scores for those two variables? And I'm going to leave everything else the way it is, and I'm going to click on compute. And so we get the result of that two-sample hypothesis test. Is there a difference between the mean score of understanding training and the mean score of, well, let's keep my skills current. And the null, of course, was 0. There is no difference. And the alternative is it's not equal to 0. Well, we see here that we have a p-value of 0.15, and that's a little bit larger than our alpha traditional alpha 0.05. So we would say no, there's no difference in that variable for between the understanding training and the skills current as far as the means are concerned. I might just take a couple of seconds here to show you what do you do with this data. Um, if you remember when I first set this up, one option is to click to store it in a data table, and it will start putting the output in columns to the right of your data. That's one way, and then you copy and paste that into an Excel file or Word document. The other thing you can do, I'm going to cancel that. Under options, you can copy this, and it gives you two ways. You can copy um, as a table, and it just says drag the mouse as a select, which is the standard stuff you do. Control C to copy it and then paste it into your document. And if you've got a graph, you can just go to options copy, and it'll make an image of the graph. And you'll see. We showed you some graphs in previous videos. So that's one way you can get this data out. The other is you can actually print. You can save this, and it will save these results, and you can put notes and tags on that. It'll save it with your session, so you can recover it later on if you need it. So there's a number of things you can do to save your data. While we have the contingency table interface up there, I just want to show you there you can run a number of different tests and gather information. What I've got here, I've selected my row variable, LPN versus RN, and I want to know, do they differ in distribution of ages? If you remember, Martha set up a number of bins to group the ages together. So we're going to do that, and I'm going to group it by male versus female. So I'm slicing and dicing a couple of different ways. We want the expected count and the chi-square test for independence again. And we click on compute, and we get our results here. And we have two tables. The first one is the continuous table for the males, and we've got, again, LPN versus RN, and these are the age brackets. And so we see that there is no difference in the distribution of ages based on males and whether or not they're RNs or LPNs. So the distributions are the same because the chi-square test is 0.26. In the bottom half here, this is for females, MF equal 2. I grouped it, and we're again looking at LPN versus RN and how they are distributed age-wise. And again, we've got a large p-value, which tells us there's no difference LPN and RN does not differ in how the number of people in each of those bins. And again, that's Duke. This is simulated data, and I didn't try to input any characteristics into that data with respect to this particular variable. But you can run a number of different options there. Let's instead of looking at age, I'm going to go over here to education and see if there's a difference on education. And we again get males and females, and 0.16, there's starting to be some difference there. It's not statistically significant for males nor for females that the level of education for LPNs and RNs, the pattern of their answers does not differ, so they're independent of LPN and RN for males and for females. And remember, if I want to go back and edit and get rid of this group and just look at everybody as a whole, then we just have one result there. This is LPN versus RN on education, and we can see again it's not significantly different, that the whole group, males and females together, LPNs do not differ from RNs. They're based on just that category. They're independent, and so that's useful.